Okay, this is like the sixth time I've tried this and it hasn't been working for me, so I'm going to get through it as quick as possible and jump through some of the graphing parts. But you have inverse relationship is basically taking the x values and the y values and switching them back and forth. If I had a bunch of ordered pair, what's going to happen with the relationship is that, again, all these y values will now become the x values, and all of the x values become y values. So basically, your ordered pair. Yesterday, I was talking about the line y is equal to x. If you were to plot those points here for the relationship and the points for the inverse relationship, they're going to be a reflection over the line y is equal to x. Okay, so here, rough sketch for parabola. Y is equal to x squared. Looks something like that. X to the third power looks something like that. That if you remember the vertical line test, what a vertical line test says that I can draw a bunch of vertical lines through my graph, and if it keeps on touching the graph once, it's a function. So both of these should pass the vertical line test because they're both functions. Some things that don't pass vertical line tests would be the circles or the ellipses and hyperbolas and maybe even some of the parabolas we did last chapter. When it comes to the horizontal line test, though, it's wondering whether or not the inverse is a function. Now, that doesn't mean that the inverse equation can't be written. It just means the inverse isn't a function. So if I were to draw a horizontal line through here, I see that it touches the graph of my parabola twice. So the inverse is not a function. Okay, whereas x to the third, I keep on drawing these horizontal lines, it never touches the graph of x to the third twice. So now the inverse would be a function. Okay, so this next one here, I've got another parabola here. Again, it's just a parabola with multiply by 2, subtract 4. So you get a little narrower parabola, but all parabolas aren't going to pass the horizontal line test, so therefore not going to have an inverse as a function. Okay, so here's how you verify without graphing whether or not it's a function. And we talked about composite functions yesterday. So I'm going to start off with f, which is 3. And in the place of this x, I'm going to leave a big old gap, but I still have the multiplying by 3 and I still have the plus 2. In its place, I'm going to put in x minus 2 over 3. Now, the 3 from the outside and the 3 from the inside, I'm going to cross cancel like I would with fractions. I'm left with x minus 2 plus 2. They're going to cancel out. I'm left with x. So half of my proof of these being inverses is already done. The other way is to start off with g. So leave out the x. The minus 2 is still there, and everything is divisible by 3. I'm going to put in the 3x plus 2. So now when I simplify the numerator, that becomes 0. I'm left with 3x over 3. The 3's cancel out. I'm left with x there as well. There's the second piece. I've now verified that function f and function g are inverses. How do you find an inverse? Well, there you go. A couple too far. If it's written in function notation, so that means f of, like these f's and with the x's in between the parentheses. First, you're going to start off by replacing that f of x with the variable y. Okay, so that's what I did right off the bat. Next, I'm going to replace x and y. I'm not going to move any of the operations, so the 1/4 is going to stay there. The y and the x just kind of change spots. Okay, so here it was y equals x squared. Here it's going to be x equals y squared. Okay, and now I'm going to solve for y. So the inverse operation of multiplying by 1/4 is to divide by 1/4, but with fractions, I'll think of it as multiplying by 4. And I'm left with 4x equals y to the second. The inverse of squaring is to take the square root. So my function is going to be y equals 2 square root of x, because the square root of 4 is 2. Okay. I'll name this guy g. So to verify whether or not my answer is correct, I'm going to take f, and where I see x, I'm going to put in my new inverse. So I'm checking whether or not the composition of f and g works with the x. If I square this, that gives me 4x multiplied by 1/4. The 4 cancel out, I'm left with x, so I'm good to go there. Flip it around. Now put f underneath the radical symbol. Okay, square root of 1/4 is 1/2. Square root of x squared is x. So 2 times 1/2 is 1. So there I'm left with x again. I got my inverse done correctly. And the way I kind of look at this is my original one dealt with x squared. I'll have square root. This one is dividing by 4. Well, I got to have some sort of multiplication in my inverse. So right off the bat, I'm looking at this guy. I think that my answer for my inverse should have plus 6 in it somewhere. And then since it's the 5th power, it's going to have the 5th root. So I'll replace it with y. I'll switch y and x around. There, to get y by itself, I'm going to have to add 6. And to get rid of the 5th power, I'm going to use the 5th root to both sides. So y equals the 5th root of x plus 6. You can verify that. Like I said, I've tried this multiple times. I've been crashing every time I try to record this, so we'll leave it like that. Yeah, and yeah, just for the sake of time and it's still working, I'm going to stop here and I can answer some questions on Friday as well.